Oh, man, there he is again. Yes, it's me again. All right. Moving on to the next section, the final section for Chapter 7, which means, yay, a test is coming. All right. Just to forewarn you, the test I'm going to give you for Chapter 7 will be online, obviously. I am going to ask you to do your work on a piece of paper, take a picture of it, and send it to me. If you do not do that, then you're not going to get credit for the test. Fortunately, I think everybody that watches these videos, you're going to do that with no problem. It's the other people that don't particularly watch the videos and try to figure this out on their own and without doing any work or anything like that. They're going to be the ones in trouble. Anyway, I'm thinking about doing something special. So for those that watch the video, give me some ideas, all right? So right in the middle of the video, I'll say, okay, text me this on Remind, and you get something special. Give me an idea, all right? If you can think of something, text me an idea. All right, here's a little bell work you can try. Try to factor these things, all right? Give them a shot. I'm going to do them, so if you can, try them. If you're struggling, it's okay, all right? You don't have to be a perfectionist at this. If you're good at it, that's amazing. If you can do a few of them, even partway, you are ahead of the game, all right? So I'm going to go ahead and do it. Recognize that the first one is the difference of two squares. This is a perfect square. This is a perfect square. This is a minus sign. So that's going to be x plus 5, x minus 5, and I'm done. All right. This one is also the difference of two squares. However, there's something in common here. A 4 goes into both of them, so I can factor that out. And I get 4 times x squared minus, what times 4 gives me 100? 25. Oh my gosh, it looks exactly like that. So it's going to look exactly like this, only with a 4 in front. You did that on purpose, Mr. Cole. I did. All right. So if you got one, you pretty much got the other. Sorry if I erased that too fast. All right. What about this one? Are there factors of 64 that give me 16? There are. And you can also notice that, hey, what's half of 64? I mean, what's the square root of 64? Square root is 8. What's double 8? Double 8 is 16. The other way to look at it is, hey, what's the square root of 16? Or no, what's half of 16? I'll get this right. All right, so the square root of 64, double it, I get this. What's the opposite of that? Well, if I have this, I get 8. If I square that, I get 64. That means this is a perfect square. You heard me saying 8. You heard it a couple times. X plus 8 squared. All right. This one does not have a common factor. 4 and 12 have a common factor of 4, but 9 throws it all away. However, look at here. What's special about 9 and 4? This is when you got to start looking at these things and saying, hey, I notice something. That's where your brain should be. Your brain should be going, I noticed something about this. I'm learning more and more math stuff, and I'm noticing stuff. When you get to Algebra 2, man, I'm going to be saying this over and over again. I'm going to be telling you and pointing things out. You're going to be nodding your heads going, oh my God, now it makes so much sense. Okay? So as you progress in math, you should start noticing things. What do you notice about 4 and 9 and 64 and 125? They're all special cases. They're all perfect squares, all right? So if they're perfect squares, then I do the same thing I did here, only instead of a 4 here, there was a 1. So I didn't worry about this one. Now I have to worry about this one. So now I look and I say 4 and 9. Okay, 4 times 9 is 36. The square root of 36 is 6. And if I double it, I get 12. I know, it's weird. Weird to think of it that way, but that means this is a perfect square. Okay? And I'm going to show you how to factor that. All right? But the other way is say, okay, I'm going to do it in reverse. I'm going to go, okay, half of 12 is 6. okay? And when I square it, I get 36. It doesn't look like 36. No, it doesn't. I got to multiply it by that. 9 times 4 is 36. Now it's fit, all right? So what that means is I can write this like this, all right? Just an easier way to do it. You can go 4 times 9 is 36. What are the factors of 36 to add to 12? Da, 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 and then go ahead and do it all out. It's a pain in the behind. It's extra work, all right? So I take the square root of this. Well, the square root of 4 is 2. The square root of x squared is x. Does 2x times 2x give me 4x squared? It absolutely does. That's my first term. And I need the square root of this. It's 3. These are both pluses, so this becomes a plus. This determines this sign, by the way. Okay? All right. There you have it. 2x plus 3 squared. Now we're going to factor completely. Okay? That means we're going to take what we've learned all through this chapter and be able to do all the factoring we can until there is none left to do. And I'll tell you what that means. All right. First off, you need to discern whether it's factorable or unfactorable. All right. This is the difference of two squares. It is factorable. You need to recognize it. Okay. That's probably the one that you're going to look at and go, okay, it doesn't look factorable. But it is. All right. So that's x plus 1 times x minus 1. X squared plus 1 is unfactorable. No, no, no. This is not x plus 1 squared. This is not x minus 1 squared. There's nothing you can do. It's done. All right. X squared plus 8x plus 7. How do I find out if this is factorable? Well, I look at this number and I say, hey, is there a factor of 7, two factors of 7 that give me 8? Most of you are looking at it going, yeah, because it's 1 and 7. Right? If I change the 8 to a 9, now I'm out of luck. I can't factor 7 to give me 9. There's no factors of 7. The only factors of 7 are 1 and 7. They add to 8. That's unfactorable. All right, so we got to recognize if something's unfactorable or factorable. Factor by grouping. You have done this. All right, if something has 4 terms, you need to look at it and say, hey, can I factor this? Okay, and you're going to group and factor. So here I got x cubed plus 3x squared plus 2x plus 6. You need to pause to write that down. Pause. Do so. All right, so I'm going to factor the first 2 here. All right, I'm going to look at the first 2 and then the second 2. All right, if I need to rewrite them to get them next to each other, I'm going to show you how to do that next. All right, so if needed, I'm going to rewrite with like terms next to each other. This is fine. All right, x cubed and 3x squared have a common factor. 2x and 6 have a common factor. So I'm good. All right, so then I'm going to go, hey, I already did this. All right, I'm going to group them. First 2, second 2. Now I'm going to look for a GCF. All right, I'm going to factor that out. So I'm going to look at this guy, and I'm going to look at this guy. And I'm going to say, is there a GCF? Is there something between those two that is common? X, yeah, good. X is common, but also x squared. All right, x, take it out. There's still an x left in there. I'd have an x squared plus 3x. Still be an x in common. Take out an x squared. I've taken them both out. Okay, so now I got to figure out, hey, what times x squared gives me x cubed? That would be x. What times x squared gives me 3x squared? That would be 3. You should be getting this. Okay, if you're not getting how I'm getting this number here, then back up and go over it 100 times. All right, you should be able to figure this out by now. You should be able to look at it and say, I know that's what needs to be there in x plus 3. All right, what's common between 2 and 6? A lot of people will say 3. Okay, and I understand why you're getting that, because 2 goes into 6 3 times. But that's not the common factor. That's what you get when you take a 2 out of 6, yes. But 3 is not the common factor. Most common thing people say is 3 right here. All right, so 2 is common. I got a 2, and 2 goes into 6. So I'm going to take out the 2. Now I got to figure out, hey, what times 2 gives me 2x? That's what's going to go right here. All right, what times 2 gives me 2x? Got to be an x, right? It's the only thing. And then what times 2 gives me 6? That goes right here. Plus whatever number times 2 gives me 3. What times 2 gives me 3? That's what I'm saying. This should be simple for you by now. If you're struggling with it, it's because you're not giving it enough thought. All right. All right, so now what did I say? Take this and put it together. All right, there's my first term, and then this is my second one, x plus 3. I'm only writing that x plus 3 once, even though it's twice up here. But it's twice because there's a plus in between. Okay, x squared plus 2, not factorable. We just figured that out. X plus 3, done. All right, so there's your answer. Either way. X squared plus y plus xy. Okay, so this is what I'm talking about rewriting. All right, x squared and y don't have anything in common. X and xy do. Can I rearrange it so that 2 and 2 have something in common? Can I move this over here? Yeah, I can. All right. What's that property? Commutative. It can commute over there. All right. So x squared plus x plus xy plus y. Now I've rewritten it with this y behind the xy. So now I have something in common here and something in common here. Now, this doesn't necessarily mean that it's going to factor perfectly every time, all right? But the ones I'm going to give you right now will, all right? So what's common between x squared and x? And x, yes. When I take out an x, I'm left with x plus 1. So x times x gives me x squared. X times 1 gives me x. That's where this comes from, all right? So what's common here? Y. When I take out a y, what do I get? Well, I'm going to have x plus 1, right? These two have to be the same. If they're not the same, it's not going to factor, all right? So if these aren't the same, they don't factor. So if you have a problem that, hey, I've taken out the common factor and these two things are not the same and I didn't make a mistake, it doesn't factor. And that's fine. That's going to happen every now and then. But most likely right now, it's going to factor. So x plus y is going to get put together and I'm going to multiply by x plus 1, all right? So you can either have x plus y times x plus 1 or x plus 1 times x plus y. All right, let's look at this one. Do I need to rewrite this? Okay, so you would think a and 3 don't have anything in common. They don't, other than 1, but that's might be okay. Look, what happens when I take out an a squared up here? I'm left with a plus, what times a squared gives me 3a squared? 3! You guys should be getting that. Okay. A squared, what's common between these two? I just told you it was 1. And I'm wondering what times 1 gives me a. What times 1 gives me 3? 3. Are these the same? They are. I get a squared plus 1. This plus 1 times a plus 3. Yeah, writing with that little pen up on the board is bad. This is awful. Anyway, I'm getting better at it, though. You could switch these up, all right? I could switch up this 3a squared and this a. You don't have to write this down. I'm just showing you another way to do it. No, I'm not. Maybe I am. Thought I was, but I'm not. Okay, same thing. You could switch these up. Okay, then you take an a out. You'd have a squared plus 1. And then over here, you take out plus 3. And you'd have a squared plus 1. All right, what about these two? I got y squared and 2x, nothing in common. Yx and 2y, they got a y in common, all right? Okay, I can take a y out of here and be left with x plus 2. That's not going to happen over here, okay? Because there's no x up here. So I need to swap these two. And you see that the y would come over here and be common with this y squared. This x would come over, not the x, but the 2 would be in common, all right? So if I switch these two, I'll have y squared plus yx plus 2x plus 2y. Totally okay to do that. Okay, it's going to be rare that you have to do that. Most often, we're going to give them to you right in the order that you need them. So now I'm going to group and factor. So what's common between y squared and yx? It's y, all right? So what times y gives me y squared? Y. What times y gives me y times x? X, right? This should start coming to you now, all right? Being able to pull that out just like that. All right, what's common between these two? No pun intended. Is that pun? Is that the right word? Anyway, 2. All right, when I take out a 2, what am I left with? X plus y. Oh my God, these don't look the same. One of these things is not like the other. However, are they the same? They are. X plus y is the same as x plus y. Especially when you say it like that. Y plus x is the same as x plus y. So I can rewrite that as x plus y. It's fine. These two are the same. 1 plus 2, 2 plus 1, same thing. All right, y plus 2 is my next one. Here's my final answer. Factoring completely when you write as a product of unfactorable polynomials with integer coefficients. So if you look at it and it can't be factored, you're done. If you can look at it and you can say, hey, that can keep factoring, then you keep factoring. If you factor something and you see something that can still be factored, you keep factoring. You keep factoring until you can't factor anymore, right? Number one, you look for GCF, all right? So here, do I have a GCF? I do. 3x will come out, right? 3x times x plus 1, I'm done. This is factored completely. Okay? I can't factor 3x anymore. I can't factor x plus 1 anymore. All right, I'm going to look for the difference of two squares or perfect squares, all right? So x squared minus 4, that's the difference of two squares, right? So I can do x plus 2, x minus 2. Wow. X minus 2, x plus 2. Should be 1 plus 1 minus. I'd be giving somebody candy now if they caught that. Perfect square. This is a perfect square. What's the square root of 25? It's 5. When I double it, I get 10. So x plus 5 squared. X minus 2x plus 2. All right. And then if it's just in the normal form of ax squared plus bx plus c, you need to figure out if it's factorable. All right. 2 times 3, 6. Negative 6, are there two factors of negative 6 that give me negative 5? Yes, negative 6 and positive 1. And then I'll go ahead and do my factoring out and my grouping and factoring, and I get 3x plus 1, x minus 2. All right, you also have to look for group and factor type problems. All right, so if you have 4 terms, this is number 4. If you have 4 terms, group and factor. 4 terms. If you're given 4 terms, you got to try to group and factor. All right. There's no other way to really do a group of 4 terms. Okay. So here's an example. 7x to the 4th minus 28x squared. What's common? All right. So first off, what's common between 7 and 28? Does 7 go into 28? It does. 7 is a common factor. What about between x to the 4th and x squared? I'm going to put my 7 down here, not up here. All right. And I'm not going to write that yet. All right, so what's common between x to the 4th and x squared? It's always the lowest exponent. Okay, I can take an x squared out of x to the 4th, but I can't take an x to the 4th out of x squared. There ain't 4 of them here. All right, there's only 2. So I'm going to take out the x squared. Now I'm going to rewrite this binomial with the 7x squared divided out of it, which means what times 7x squared equals 7x to the 4th goes right here. All right. Yeah, it's x squared. I looped. Right? Minus what times 7x squared gives me 28x squared. So what the x squareds are there, so I don't have to worry about them. So what times 7 gives me 28? That would be 4, right? Boom. I'm done. No, I'm not. Can this be factored? It can be. I wrote it right. There it is right there. X squared minus 4. All right, so x squared minus 4 can be scrap factored into x plus 2, x minus 2, or x minus 2x. So, is it completely factored now? It is. All right, I can't factor this anymore, can't factor this anymore, can't factor this anymore. It's done. If you'd like to try one, go for it. This one does factor completely. Huh, they all factor completely. Just might have to do something or not have to do something. So, GCF would be first, then factor trinomial would be second. Is it a perfect square? I don't know. I don't think so. So pause and try if you want to. Or wait for me and I will do it. What's common? Well, is 3 go into all 3 of them? It does. Is there x in all 3 of them? There is. So 3x is your first factor. All right? So when I take out a 3x, I'm left with x squared, right? 3x times x squared gives me 3x squared, plus what times 3 gives me 6, a 2. And I have x here and x squared here, so I need another x here, right? So x times x gives me x squared. And what times 3 gives me 18? That would be 6. All right, so 3x times negative 6 gives me negative 18x. Does this factor? Do I have negative 6 factors that give me positive 2? 3 and 2 and 6 and 1. Difference here is 1. Difference here is 5. Negatory. I'm done. This can't factor anymore. Okay? Doesn't factor further. There's no factors of negative 6 that give me positive 2. So sometimes this is going to happen. All right. Now I'm throwing in another, I forgot to tell you at the beginning. We're going to learn how to factor completely, and then we're going to solve equations by factoring, which you've already done. What's the first step when I see these things? 90% of the time from here on, you're going to set equal to 0 to solve. Not 100% of the time, 90% of the time. All right? So set it equal to 0. So first things first, move this 10x over by subtracting. All right, so I got 2x cubed plus 8x squared equals 10x, and I'm going to subtract 10x from both sides. That's not going to combine with anything. It's going to remove the one from the right and make it 0. And it's going to place negative 10x on the left along with the other two terms. Okay, it is not going to combine. You should know that by now. All right, so I get 2x cubed plus 8x squared minus 10x equals 0. Now I'm going to employ all those things that we just did. All right, so go through that list. The first one is GCF. Is there a GCF? There is a GCF. What's common between 2, 8, and 10? My first step is always saying, hey, does this go into all the rest of them? It does. Okay, what else goes into all the rest of them? What's the lowest exponent of a variable I got here? It's x. All right, x to the first. I can't take x cubed out of x to the first. I can't take x squared out of x to the first. But I can dang sure take an x out of x, and an x out of x squared, and an x out of x cubed. All right? So now I need to figure out, hey, what times 2x gives me 2x cubed? The 2's already there. I need a 2. I need a 2 added to this 1. So I need an x squared. 2 times what gives me 8? Well, that would be 4. And I need another x, right? Because I got 1 here, but I need 2. So it's going to be 4x. And what times 2 gives me negative 10? 2 times what gives me 10 is 5, but it's got to be negative. I've already got my x, so I don't need that. So 2 times negative 5 gives me 10. This equals 0. Do I know what one of my answers is right off the bat? If I have a variable slammed up next to a parentheses, one of my answers is 0. You should have that answer before anything. You should have kind of saw it here, right? Because if x is 0, all of these are going to be 0. So I know x is going to be 0. So x is going to be 2 other numbers as well because I've got x squared. All right, that's going to factor into 2 binomials. So what are the factors of negative 5 that give me positive 4? Factors of negative 5 that give me positive 4. Well, the only factors of 5 are 5 and 1. So this is going to be them. How do I combine 1 negative and 1 positive to give me positive 4? Negative 5, right? So negative 1, right? So x minus 1, x plus 5, 5x minus 1. So here I got x equals 0. Here I got x equals negative 5, right? I'm going to subtract 5, so I get x equals negative 5. Here I got x equals positive 1 because I'm going to add 1, and I'm going to get x equals 1. Bada bing, bada boom, bada bang. I have enough practice. All right, here's a little word problem. Box in the shape of a rectangular prism is shown. It has a volume of 96 cubic inches. The dimensions are given as shown. Find length, width, and height. All right. So how do I find the volume of this box? I go this times this times this. That means x minus 2 times x plus 8 times x equals 96. Okay? So Now you got to employ a whole bunch of stuff here. I got to FOIL this out. Okay, x minus 2 times x plus 8. So I get x squared plus 8x minus 2x minus 16. All this is still times x. Don't forget this x. Still equals 96. All right. Combine these two terms. I get x squared plus 6x minus 16. Still times x equals 96. What do I do with this x? Divide it? No. Distribute it? Yes. All right. So distribute it. X cubed plus 6x squared minus 16x equals 96. What'd you do there, Mr. Cole? I did multiply this x times everything inside. Okay. X times x squared gives me x cubed. X times 6x gives me 6x squared. X times negative 16 gives me negative 15x. What do you do now? Oh, my head hurts. Set equal to 0. How do I set equal to 0? How do I make this 0 over here? Can I subtract 96? I can, but I can't combine it with anything over here. Okay. So it's going to wind up being x cubed plus 6x squared minus 16x minus 96 equals 0. Okay. X cubed plus 6x squared minus 16x minus 96 equals 0. This is all the work I just did. Okay. It's kind of condensed. I skipped a step here and just combined them as I did it. Right. My x is on the left side instead of the right side. That's the only difference there. Only two differences is I combined my 8 and negative 2 to give me this 6, and my x is on the left. All right. Everything else here is exactly the way I just did it. Now, I have 4 terms. If you see 4 terms, you should think group and factor. What's common between x squared and x cubed? All right, there's a 1 and a 6, so we don't worry about numbers. X cubed, x squared. I can't take an x cubed out of x squared. I can take an x squared out of an x squared. All right, so now I'm saying, hey, what times x squared gives me x cubed? That's x. What times x squared gives me 6x squared? That's 6. This needs to be x plus 6, all right? If this isn't x plus 6, I'm done. I can't do anymore. I'm kaput, all right? So I've got a negative and a negative that need to become positive. So this is going to mean I'm taking out a negative. Now I need to say, hey, what times 16 gives me, what times x gives me 16x? Oh, well, that's easy. It's 16, isn't it? Is 16 times 6, 96? It is. All right, so now I'm going to rewrite this. A lot of work here. It's okay, though. X squared minus 16, x plus 6. Oh, my gosh. What just happened here? Equals 0. All right, recognizing this is a special case. All right, you got all kind of stuff going on here, right? This is like everything we've done put together. I can factor this, x plus 4, x minus 4. I still got x plus 6, and this is equal to 0. This is factored completely, but it's equal to 0. So how do I figure out what x is? All right. So this is equal to 0. So if I subtract 4, I get negative 4. This is equal to 0. So when I add 4, I get 4. This is equal to 0. So when I subtract 6, I get negative 6. So here are my answers. Let's see. My width right here is x inches. Can I have negative 4? Nope. Can I have negative 6? Nope. So that means it's going to be 4 inches. But it says find the length, width, and height. All right, so my width is 4. My length is 4 plus 8. So my length is 12 inches. And my height is 4 minus 2, which is 2 inches. All right, so I got 2, 4, 12. Okay. There it is. And now you have a lesson 7.8. And that is it. So FYI, there will be a test. It will be early next week, probably Tuesday. Hope there's nothing major going on. I am going to be on the water, so you will see me with some water and birds behind me when we're doing that. When we're getting ready for the test. All right. So make sure you do the homework. Make sure you're following along what I'm doing. I hope everything's okay. I hope these are helpful. I need a haircut. Oh my gosh. See you guys.